Okay. Now, I don't know what happened to my record ability. Oh, I got it here. Okay, well, it's about 9:04. So, oop, there's June. Okay, it's about 9:04, so I suppose we ought to get underway. Tonight, of course, we're doing safety, and it's not a difficult chapter. We'll breeze through it pretty quick. Um, let me see. Okay, is everyone seeing my screen?
Yes.
Yeah.
Okay. But let me stop just a second and make sure that I am. This computer. Okay.
Unfortunately, since I'm dialed in, I have to use my imagination.
Oh no. Well, on the plus side, Brad, on the plus side, you've already passed your exam, so.
Okay, well, Brad, if you have your manual, we can just tell you the page we're on. It'd be on section 9.
It'd be roughly. Yeah.
I'm sitting here in the dark pretty much, so
Oh, okay.
I don't think that would help much either.
Okay. Yeah, what we're talking about is electrical safety, radio interference, radio frequency exposure, and mechanical safety. This is all pretty, cut and dried stuff. The big thing I want you to get out of this is first off that it takes very, very little amperage to give you a jolt. Now, you can get a jolt out of a lot of voltage with a tiny, tiny amount of amperage. Like, for instance, think about, walking across a carpet during the winter, during the dry months of winter, and touching a brass doorknob and getting a jolt. Well, that jolt you're getting is anywhere from 1,000 to 10,000 volts, but it's a tiny, tiny, minuscule amount of amperage. Volts jolt, but it's amperage that gives you a problem. When you look at the table on table 9.1, which I think is on page 2, it gives you kind of it gives you a table of values for what a small amount of amperage will feel like. Now, it's giving you milliamps. So these are thousandths of 1 amp, thousandths of an amp, and thousandths of an amp can cause you, some real discomfort. Even 1 milliamp is just, you'll feel it. It's tingling. 5 milliamps, you'll feel a light shock. But you get up around 25 milliamps, 20, 25 milliamps, 30 milliamps, and it's a fairly painful shock. And up from there, it's worse problems. There's two big things that happen. One is just when you insert yourself in a circuit, you become a resistor, and how does a resistor get rid of electrical energy? And it does so in terms of heat. And so yes, you can get skin burns with a little bit of electricity. The other thing, if the amperage is high enough, is it can cause voluntary muscle contractions. Now, this can be, just jerking, or it can be like seizing up, both of which can have disastrous effects. If your hand grips, a live wire and you can't let go of it, you're going to be injured. Or if you get a big shock and you get a jolt and you're holding some kind of a tool, um, like a screwdriver or something like that, you can end up causing damage or injuring yourself that way also. Um, and the book goes into these steps for working on electrical projects with the power on. First off, it's better to work on projects with the power off. If you're working with power on, you shouldn't be doing that as a novice, as a rookie. Leave that to the people who really know what they're doing. But they give you all these nice little tips. Keep one hand in your pocket. And the idea there is, if you're going to take a shock, that's fine. But you don't want both hands in the electrical appliance, because you don't want the electrical current going from your right arm to your left arm, or your left arm to your right arm, because in doing so it passes your heart, and that's very, very bad. It talks about wearing insulating shoes so you're not directly in the part of the circuit. It tells you about not bypassing safety interlocks. Much of your equipment will have a safety interlock, so where if you remove the cabinet of the equipment, it automatically shuts off. Of course, you can bypass those safety measures. And for professionals, there's times they need to do that. Oh, capacitors. Remember back in chapter 5, or was it chapter 3? We were talking about parts, and Jerry explained how the whole purpose of a capacitor is to store electrical energy, and it stores it in a magnetic field. Well, when you turn off an electrical appliance that has capacitors, those capacitors are holding charges. And if you complete a circuit, and if you're part of the completion of a circuit with a capacitor in it, it will discharge its energy to you, and that's not good. And the other obvious things: keep metal objects clear of storage battery terminals. Yeah, you want to be really careful of that. If you take like a car battery, a 12-volt car battery, you don't want to be working with anything that you can drop on it that's going to connect those two terminals to each other. A car battery, although it's only 12 volts, it can, for a short period of time, it can develop up to 600 amps. And if you go back to that table, you remember they're talking about milliamps. 600 amps, a car battery doesn't generate that for a long time, instantaneously, but still. You remember, it's got to crank over your engine. So yeah, it's a lot of power for a very short period of time. Having problems with car batteries that you may be using to power your equipment, that can be dangerous. That can be dangerous. It's like, this is a really, really safe hobby. You know that? I mean, it really is. Every now and then we hear of one or two people, dying for different reasons. But skiing, what, about 4 dozen people a year are killed in skiing. Boating, 600 or so people regularly are killed per year in boating. Hardly any deaths occur from amateur radio. It does, though, happen from time to time. Um, I sometimes joke about this chapter being, it's about safety, comma, don't fall off the roof. When people have fatal accidents in ham radio, it's not usually from working on their radios, it's from working on their antennas. And here's uh, a little article. I saw this a couple of years ago in one of the ham radio magazines, but I can't find that magazine anymore. But ARL published this a while ago about some guy that died because his tower. He was up working on his tower, and his tower collapsed and fell. Uh, and there were a couple incidents of that. The other way people have terrible accidents with antennas is when they're working on antennas and their antennas fall into a power line and a utility power line and delivers lots and lots of electrical energy right to them, and that's very, very bad. Okay, back to okay. Oh, and avoid working alone. This is going to come up several times. This to avoid working alone. Especially if you're new at these kinds of things. Now, grounding. You know, for for errant current, you need a place for current to go, and so your equipment, your station needs to be grounded. Your station, uh, there's two types of well, there's sometimes called two types of grounding. Really, one is called bonding, but grounding is taking care of electrical energy. Um, the safety ground is a connection to your power system. Yep, reference to the main electrical service box. There's ground connections and circuit breakers to remove power from equipment. Um, you know, on your equipment, always use those 3-wire cords and make sure everything's connected to ground. Hey, and those ground fault interrupter circuits, those are especially good in using and keeping you safe. And of course, verify that your alternating current wiring is done properly. And this you probably heard this since you were a kid, is that if you've got circuit breakers or fuses, don't replace a burned out fuse or a worn out circuit breaker with one of larger current size. Those circuits are made to carry a certain amount of amperage, and you don't want to you don't want to work around um, your safety uh, measures. Okay. All right. All right. Wiring. U.S. wiring. Of course, the black wire. They say occasionally red, but I have never seen that. But black wire is the hot wire. The neutral wire is white, and then there's a green wire, or sometimes just a bare copper wire, which is the ground. And if you're building projects, use the right size of wires. There's a nice little table in the book telling you what the current capacity is for different gauges of wire. Lightning protection. Oh, okay. Starting with things. Yeah, you've got to do lightning protection. If you're if you have a big antenna going up into the sky, that's like a lightning rod. And so you've got to, protect your home and your equipment, but first and foremost, your home from lightning strikes. Okay. All right. Starting with your antennas. First off, the very basic thing is to start according to your local building and electrical codes. That's must. And that's just the starting point, all right? Your tower, if you're going to have a tower, if you're going to have a tower, you need grounding rods on those towers, and the grounding and the connections to the grounding rod. To to get the stray electricity to ground, you want to provide it as short a path and as straight a path as you possibly can. So, you're going to be connecting grounding rods. If you've got a big tower, you're going to connect the legs. Each of the legs is going to have a grounding rod connected to it. That grounding rod's going to, should be, like copper and about 8 feet to be driven into the ground. And they should be bonded together, meaning they should be connected by wire or some kind of either wire or heavy strap, and they should, again, be connected firmly, securely to the grounding rods. Jerry?
Yes.
Oh, okay. Jerry, what? Can we show the picture of your tower and the grounding system you've got with your tower?
Okay, I'm going to have to take a look for it, but I'll let you know when I find it.
Oh, okay. Okay, fine. Well, then I'll just go on then. Okay. Now, managing RF in your stations. Okay. Now, your stations, the wiring, the power connections, they all the wire has the ability to pick up radio frequency, radio signals that you're transmitting. You don't want that to happen because, those connections, those wires can radiate power and mess up, other equipment in your house. Just like they can also collect signals from other implements in your house. Okay, so yeah, you don't ground your equipment in the same way you connect the basic power ground, the AC current grounding. You do this by what they call bonding, which just means that all the equipment in your shack is connected to connected by wires. You'll see that most of your equipment will have a screw on the back for grounding. So you connect a wire to that out back a little bit to a copper strap, and the copper strap should be behind all your equipment, and your equipment should all be connected to that. And currents and cables and closures can cause audio distortion, erratic operation. Okay, yeah. Okay, bonding tips. All metal equipment enclosures should be connected to a common ground bus. That would be something like either a very heavy copper wire or a copper strip, something of that nature. Solid strap is best, and solid strap is best because it presents the lowest impedance. And to carry away this RF, you want to give it the easiest path you can give it to go skirted away safely. All right. And again, keep all your connections, straps, wires as short as possible. Remember, there are antennas made simply from long wire. And, those connections you make from one piece of equipment to another, that gets very long. And if it's unshielded, that can radiate, that can act like an antenna, just like the one you actually want your radio signal to go to.
Yeah, Bob?
Yeah.
I've got some stuff on grounding, if you like. So if you want
to,
let me share screen. I'll.
You got it. Go ahead.
Okay, share screen. All right. Okay. Yeah. Can everyone see this?
Yes.
Okay. All right. First of all, here's a diagram. I talked to different people about grounding before I put my tower up. And one of the guys said, "Oh, I have one ground lead to my tower. Oh, it's broken." Another guy said, "Oh, I just grounded through the cement block that's buried in the ground. Don't think like that's a good thing because the lightning will go and crack the cement block." According to the electrical code, each leg of the tower has to be grounded. And there are some people who use multiple ground rods on each leg. Like this is an ideal diagram. I have three, just one on each leg of the ground. These are 8-foot ground rods, which are pounded down as far as I can go. They are attached with number 8 wire. It could be, which is a fairly thick wire with no bends. You're going to have a question in there, I think, asking whether you should have the right angle bends and things of that sort. These wires should not be bent. It diverts the lightning. And they're all bonded together. There's actually a wire that circles each of the legs and make sure that all 3 of these are circled. Let's see. Okay. This, can you see this?
Yes.
Okay. This is as much as I could get into the ground. Here's a clamp, and you can see the wire, the special clamp that goes through the pole. These 8-foot ground rods are readily available over at Home Depot at not that much of a price. And in order to pound it down, there's some people who will soak the ground with hot water and try to wiggle it down. I used a 15-pound sledgehammer. These weights would go up and down and keep pounding until it got down as far as I could. And one other thing, as far as as far as lightning protection. All right, I have these 2 plastic boxes, which they look kind of official. They're waterproof. They're used by phone companies and stuff like that, and they're readily available on Amazon for I think $15 or $20. And what happens? I have a surge arrestor. I have 3 of these for the 3 antennas that are on the tower. And what they do is they try to divert as much of the lightning strike, or full lightning strike is not going to protect you from anything. You're going to roast. But if it's just a surge high voltage electricity coming down the tower from the atmosphere, it will protect your equipment. There's a little button type of gizmo gas discharge thing, which will divert the pulses, electrical pulses, down to ground. And here's how I have it set up in inside the box. Each of the arresters are attached to a metal bar. You can see over here, there's that's a number 8 wire that's going to the ground rod. And they go from the antenna through the arrestor and then to the equipment. And well, you can see here, this is where one of the arresters is attached to the bar. I also put a connector and attached the wire to it. This is an aluminum bar, so I had to be very, very careful that I didn't have the aluminum contact the copper wire directly. Otherwise, you're going to have deterioration, electrolytic deterioration and rust. And let's see, that should pretty much do it, except for the fact that I had these ground rods sticking out. I did not want this to happen. So I got a plastic flower pot and put it on top. And there we rest. Okay. Back to you, Bob.
All right. Because I love showing them that real world stuff. It's so much better than just pictures in the book.
Mhm.
Okay, filters. Whoop. All right, yeah. Interference between appliances and your radio. That's radio frequency interference. You use filters to avoid that. The thing there are power line filters, to keep radio signals from passing into or out of equipment, and they reject, signals, with frequencies greater than a few kilohertz. But there are also something called these ferrite chokes, and these can be little. Let's see. I think we have a picture of them. Well, okay, yeah, here. These can be, small little things that snap together over electrical cords. You see these two down here in the lower left. That's something like that. And over here on the right, also, these would be like filters that if you were having radio frequency, bleeding into your television set, you would put this on the antenna line, the antenna line input to your television. So this would block radio frequencies from, getting into your television. Oh, and ferrite. Remember the word ferrite, okay? Because there's a question on the test that asks about that. And so it's ferrite chokes or ferrite core filters. Yeah. All right, now interference from amateur transmissions. There are three kinds. One is called fundamental overload. There's harmonics, which we've talked about way back in chapter 2, and then there's spurious emissions, which I think we also touched on back in chapter 2 or chapter 4. The fundamental overload, that would be like something where just a super powerful signal just overwhelms your radio's ability to reject that signal. I would imagine that there could be people like in Jerry's neighborhood. There's a huge tower, and I forget what station that is, but just
There are about 5 or 6 huge
a little bit to the west. What is it?
There are about 5 or 6 huge towers. This was the outskirts of Detroit 50 or 60 years ago. So they put all the antennas out here. And I'm enjoying all these spurious emissions and overloads.
Yeah, but like those can be radio stations, broadcasting with 50,000 watts. Well, your radio that's meant to handle, 100 watts or something, that's an enormous imposition on it, and it takes some advanced, filtering to keep that out. Your televisions and your radios, your commercially built stuff is supposed to have enough filtering to reject those things, but doesn't always. Things that can help things like that are something called a high pass filter. And a high pass filter is one that will block, it's meant to allow frequencies of above a certain level of megahertz and block everything below that level. That's a high pass filter. So it's letting high frequency go through, but blocking lower frequencies. There's something what they're calling down here a broadcast reject filter. No, this is something different. This simply is made for keeping out, commercial broadcast stations, AM, FM, or television. There is also something called um, a notch filter, which can block out a specific range of frequencies, just a specific range of frequencies, and let frequencies above that range through and frequencies below that range through. And that would be particularly useful if, well, if we were near a like a broadcast shortwave station, which would be maybe uh, well, in other parts of the world there are broadcast shortwave stations, around 7 megahertz, which is kind of, it's near our 40-meter band. And you can get filters that can block out specific filter ranges that would uh, help keep those signals out of your out of your radio. Okay.
Bob, if I can just give a little historical thing. 6 meters is not very popular in the Detroit area for a reason. When I was a kid, we would operate on 10 meters, which is 28 to 29.6 megahertz. And the second harmonic would be around 56 megahertz. Channel 2 operated from 54 to 58 megahertz. So there was an awful lot of television interference. TVs didn't have very much in the way of filtering at all. So what would happen, Allied Radio and some of the other local places would have a high pass filter that you'd put on the antenna terminals of the TV set. And we hams would buy a low pass filter, which would attach to the transmitter, between the transmitter and the antenna. By doing that, we would try to keep any harmonics and any inkling of radiation at the harmonics out. And at the TV set, the high pass would keep any of our ham frequencies out of their TVs. They weren't very good, and we still had people complaining about it. And it's I wish I could say that this is an FCC licensed amateur radio station, and we can do whatever we like, and to heck with your interference, which is one of the possible answers on your question on your exam. But if you say that, you're going to be wrong. Okay.
And impolite, and
Oh yeah.
that's no good. Okay. All right. Leakage is another source of interference. And leakage just means, if you've got faulty connections, and you could be, sending out spurious signals that you don't intend, and that does no one any good. So, one thing that's going to keep coming up is you need to make sure you're keeping your station in good working order. Now, this means that that you're grounded, that you've got radio frequency grounding, that your connections, your coaxial cable connections, or whatever feed line connections, or whatever feed line you use, the connections are solid, that they're good and not sending out spurious signals themselves. It's very, very helpful if you're using coax, because of course coaxial cable is shielded in itself. If you're using ladder line or open wire line, of course, then your feed line could be radiating radio frequency, and that's not good. That it doesn't do you any good, and it doesn't do anyone else around you any good either. Okay. Oh, radio frequency interference and neighbors. Yes. First off, the first thing to do, just make sure your station is in good working order, and that you aren't indeed sending out any signals that aren't doing anyone any good. If you're receiving radio frequency interference, again, the first step is make sure that your standard, that your station is in good condition and meeting, good operating standards. Um, oh, and they say, you can offer to help find the source of the interference. This would be if maybe the interference is coming from a neighbor or, some appliance they have, which is perhaps in working order. And you've got to remember, under FCC rules, we are licensed, and non-licensed appliances or equipment is not supposed to be interfering with us. We shouldn't be interfering with other people's, TV and radio, but their equipment shouldn't be interfering with us. And like Jerry said, yeah, you really could tell them, we're protected, we're licensed, we're protected, it's your problem, but that's not a good way to do it. Okay.
Bob, before we get into the RF exposure, I will say that there are certain types of devices that can cause an awful lot of interference. There's something mentioned in QST magazine this month about a fellow tracking down the source of interference, which was blanking out his entire station. Turned out to be a battery charger in a neighbor's garage.
Oh.
And those a few years ago, there was those touch lamps. You touch it and it turns on or gets more intense. And those things, the circuitry there would cause interference to amateur frequencies. Also, something that's very handy to locate things is a small AM transistor radio. It's got a bar antenna, so you can twist and turn it to locate where the source of the interference is.
Mm-hmm.
Go ahead.
Okay. Yeah. Those touch lamps, I don't see those much anymore. It's been years since I've seen one. They used to be very popular, but not so much anymore.
You see them at garage sales now.
Oh, what's that?
You see them at
You still
garage
have one?
sales.
Huh?
You see them at garage sales.
Oh, garage sale. Okay. All right. Okay. We keep talking about radio frequencies and electromagnetic waves and electromagnetic wave radiation. Yeah, bear in mind that, of course, this is low frequency and relatively low energy, and this is non-ionizing radiation. This is not the kind of radiation you get from a nuclear weapon. It has no ability to cause damage to your genes or your DNA or anything like that. It just hasn't got that level of energy to it. Okay. Now, however, that doesn't mean that radio frequency energy cannot cause harm, because yeah, it certainly can. If you have someone grabbing into your antenna while you're transmitting, they're going to get not just depending on how many watts you're using, they may get just a shock, just a good jolt, or they may get an actual RF burn, because with enough energy, yes, this RF energy coming out of your antenna can actually cause burns.
It's painful and it's hard to heal.
Yeah, painful. And you've got to be careful, because different parts of the body absorb radio frequencies at different, or radio energy at different frequencies than others. And I think there's a table in your book that discusses that a little bit, although it's not you won't be tested on it. Okay, you'll be tested on other general things. All right. Uh, RF burns can be eliminated by properly binding techniques and more important, by preventing access to your antenna. You know, um, now this I want you to look at and kind of get a good look at. This is, you remember what we're talking about here is, preventing um, injury to other people, to yourself and other people. And what we're talking about here is power density that's allowed, that's safe. Okay, power density in milliwatts per cubic centimeter. The when you're way down and say the 180 meter or the 160 meter band, or even the 80 meter band, um, uh, in a controlled environment, up to 100 milliwatts per cubic centimeter is okay. You'll see it on this chart right here. Now, as the frequency increases, the maximum permissible exposure decreases to a certain point. Okay. Now, you've got to look in this area that I've colored in yellow, because this is the area where where the maximum permissible exposure is the lowest, meaning you have to be most careful here. And what I really want you to see is, remember, we were talking about frequency ranges, and this is the 30 megahertz to 300 megahertz. And that is exactly the range of VHF, right? So 30 megahertz right here on the graph, 50 megahertz, which is the 6 meter band, is just a little bit to the right. About in the middle is 145 megahertz, which is the 2 meter band, which is a favorite band of technician licensed people. All right. This is an area where the maximum permissible exposure is lowest. All right. You've got 1 milliwatt per cubic centimeter for the controlled area. Controlled area, and again, controlled area means an area where people know that there's exposure and can do something about it. So that's you and your buddies sitting there in your Radio Shack. You're in a controlled area, but the people outside, and remember, your antenna usually is going to be outside, not always, but usually is going to be outside. People outside may not be hip to that. And it's your responsibility to be to take extra precaution to see you're not causing harm to those people who are who are not your unindicted co-conspirators. Okay. All right. So I want you to remember this. There is a question that could pop up on your test that asks you something. Which of these frequencies has the lowest maximum permissible exposure? And they give you 4 different frequencies. A couple of them are very low frequencies down here in the HF area. There's one that's around 440, which is up here in the UHF area. The only one that's in the VHF area is 50 megahertz, which is the 6 meter band. All right, so if that question pops up, the maximum permissible exposure, the lowest maximum permissible exposure, that is the 50 meter band, because it's in the VHF range, 30 megahertz to 300 megahertz. Okay. Now, exposure limits. We already talked about that. Exposure limits, controlled and uncontrolled, and frequencies at which the body has the highest rate of absorption are in 30, the highest rate of 30 megahertz. Well, they say to 1500, and it's really 30 to 300. Yes, you'll see that in the UHF and the UHF and the super high frequency area, it's lower than in the low frequency, but it's still much, much higher than the VHF area. Okay. Average duty cycle. Now, when we're talking about the exposure, remember, we're not talking about when your radio is turned on. We're talking about when you're transmitting. If people are out there grabbing onto your antenna and you're not transmitting, they're not going to feel anything. You can receive all you want. When it can cause danger is when you're transmitting, because that's when you're sending electrical energy, electromagnetic energy out through your antenna. All right. And so that's why duty cycle matters. To do the calculation of maximum permissible exposure, you go through this calculation, and one of the things they ask for is, well, how long are you going to be transmitting? Because again, it doesn't make any difference when you're not transmitting. That's they need to know the amount or the percentage of time you'll be transmitting, because people are not going to be getting exposure when you're not transmitting. All right. Now, yes, now we are supposed to be performing these exposure evaluations. There are 3 ways to do it. One is using the techniques outlined in the Office of Engineering Technology Bulletin 65. Oh, yeah, let's do that. Except, okay. Except, oh, damn it. Here's Bulletin 65, and it's all glorious 57 pages of small print, very technical, very boring. It's got some tables in here, and that's fine, but there's easier ways to skin this cat. There's ways to measure your power density of your transmissions. You do it yourself, and there's basic computer models. I'll tell you what, the easiest way to do it, though, is ARL provides, see if I, oh, that's not it. Hang on just a second. I'll be right there. I don't want that. Stop, oh, that's fine. Stop screen sharing. Okay. Now, let me get back to. All right, now. Why am I not seeing that? Okay, can you see this?
Not yet.
I'm not sharing. Okay, hang on. Screen share. Okay, how about now?
Yeah.
Okay, all right. Out on the ARRL website, if you put in the keyword search RF exposure calculator, they have this nice little model down here where you put in your antenna power, you tell it what kind of duty cycle you're doing, and it'll give you this one right now. I can't use the drop down box right here, but it drops down single sideband, with a 20% duty cycle. It gives you CW and a couple of other choices. It asks you for your transmit time and then your listen time, asks you about your antenna gain, and then your operating frequency. And it will, down lower on the form, it will come back and give you your maximum permissible exposure. It'll do the calculation for you. It's very cool. Okay. All right. So that's that. You do this once, and if your equipment stays the same, you're good. You're done. But if you start changing equipment, especially, if you get something like a linear amplifier that instead of you broadcasting at or transmitting at 100 watts, now you're going to be transmitting at 600 watts or 1,000 watts or 1,500 watts, then you should go through this again. You should also do it if you change antennas, because if you're using an omnidirectional antenna and then switch to a beam antenna, a directional antenna, that's going to have an effect because the directional antenna has a different propagation profile than does an omnidirectional antenna. Okay. Safety measures. The easiest thing is, just if you get your antenna in a place where people can't get close to them, you're pretty much good. Because remember, it's not where your radio is, it's where your antenna is, because your antenna is the thing that's going to be radiating the power. All right. That's the thing that's going to cook people, if anything's going to cook people. Okay. The other thing, of course, is raise the antenna, because you want to keep the antenna away from people. And if it's high enough up, if it's 50 feet up, that's significant less likelihood that someone's going to come in contact with it. All right. Beam antennas. Now, with beam antennas, you have another consideration that you would not have with an omnidirectional antenna, and that is the beam antenna concentrates all the power in one direction, so that you need to be careful. Where are you pointing that thing, mister? So, all right, and of course, in times when you want to transmit, but there are a lot of people around, you can always just lower your antenna gain or reduce your power, or reduce the power of your transmissions. What they're talking about here about mobile antennas is if you put it on the roof of your car, assuming your car roof is metal, that will shield the passengers inside from RF emissions, and it should be, and if you put an antenna on it, it should be metal, because the metal roof also serves as a ground plane and reflects up radio waves and helps the reception and transmission. All right, if the roof of your car is some kind of plastic, then first off, it's not going to serve as good. It's not going to help your antenna reception, and it's not going to protect the people inside the car when you start transmitting. Okay. Mechanical safety. Oh yeah, this is the don't fall off the roof part. Okay. Now again, when we started talking about electrical safety and grounding, the first thing we started with is talking about public electrical code, local zoning, local electrical codes. And here, when we're talking about antennas and putting up antennas, again, you need to start with making sure that you're keeping consistent with your local zoning codes as to what you can and cannot do. Okay. Now, putting up antennas, whether it's a tower or just an antenna on a large mast, you've got to keep clear of power lines. Those power, if your antenna, which is basically a conductor, comes in contact with the utility power lines, it's going to conduct all kinds of electricity down to you. That is another way people get injured. It doesn't happen very often, but an antenna falling into a power line can have disastrous consequences. Okay, now the book, and in fact on the test, there can be a question, asking you, how far away should you be from power lines? And the rule of thumb is you got to put up your antenna and think about when it falls. If it falls, will it fall at least 10 feet away from power lines? At least 10 feet away. And, more is better. All right. And they're telling you, of course, never attach your antenna to utility poles. And again, they go back into grounding your tower with separate 8-foot long ground rods, and then, bonding the tower to, each of the grounding rods. And you know what? And they keep having this question on the test, and I don't know that many people that use these turnbuckles to hold up, their towers or their or their guy lines. But anyhow, there is a question that asks, why should you use a safety wire through a turnbuckle that's used to tension guy lines? And the answer is, you put a wire through there to help prevent it from loosening due to vibration. Okay, because the wind is going to move your tower or your mast at least a little bit, tiny bits, but over the years, over the months and years, yeah, it will loosen up your guy lines or your other supporting devices. Okay, tower work, yes. One of the big things they're going to tell you about tower work, again, is don't work alone. All right, don't work alone. There's a question on there asking, I think it asked something like, when can you, or when should you work on your tower by yourself? And the answer is never. And if you're climbing the tower, if you have one of those crank up towers, you need to mechanically block off the tower so that it cannot collapse when you're up on it. That article in ARRL that I showed you before, where the guy died, what had happened is he was up on the tower and they were trying to take it down, and the tower just collapsed. He was 40 feet in the air and the thing collapsed, and he came down with it. All right, and they tell you all the other normal stuff. Check your safety equipment before you go up. Make sure your ropes are good and that they're appropriate for the job you're doing. And to double check the latest weather report. Yeah, don't be climbing in a thunderstorm. Okay.
Hey, Bob, do they still have that thing about gin poles?
Oh, they did. Yeah, they did. Here, hang on.
I got
Where
a
is
picture of a gin pole.
Okay, yes. Oh, if you use a gin pole, so you do not have to hoist. Use a gin pole so you do not have to hoist things directly. Okay, yes. I came to this, and this is one of those questions I just memorized because I didn't actually know what a gin pole was, but it's just a pole you use to help support equipment as you lift it up the tower. Okay, Jerry, take it away. Oh, let me here. Hey, hang on. I'll stop sharing. Go ahead, Jerry.
Okay. Okay, yeah, everybody see this?
Yes, yes.
Okay, and what it is, it's I don't know, this guy's going to be doing really fancy stuff, but he's hoisting up the sections of the tower, and the gin pole will elevate the tower above the section that's there, so he could fit it on and bolt it down. I hired a company to put my tower up, and the fellow didn't have to have a gin pole. The sections were light enough, but he'd go 8-foot section by 8-foot section, bolt it down, and then the guy on the ground would help him hoist another section of tower out of the rope, and that's how he did it. Other people have erected towers on the ground, and if you have enough people, you can just manhandle the thing up. Just start at the top when it's on the ground, and just keep on pushing it up until it's finally flops over vertical. Okay.
Okay. Okay, tell you what. Let's look at the questions. No cues. And I'll tell you what, I'm just going to do these kind of quickly from the beginning. All right. How are we doing? We're doing great. What I want to go through is I just want to go through the questions from this chapter that could appear on your exam. Again, you review on these last 4 administrative subject kind of chapters. I want you to be able to go in and get 100% on these 14 or so questions. So you got yourself a good cushion when you get into the technical parts of the exam. Okay. All right. So now you'll notice that I've gone through and I've actually highlighted the answers because, I want you to get kind of rather than spending time, because I want to get through all of these. And so rather than spending time, having you read through each of the wrong answers, we'll just go right to the right answer and discuss the question. Okay, so this one, of course, what's the health hazard presented by electrical current through the body? And that, can it cause injury by heating tissue? You bet it can. Can it disrupt electrical function of cells? Oh, yeah. Yeah, that's like disrupting electrical, like stopping your heart. Yeah, that's a problem. Can it cause involuntary muscle contractions? You bet. In this case, this is one of the actual questions that could appear. The answer is all are correct, all those choices. Okay. What hazard exists in power supply immediately after turning it off? And remember, those capacitors, the whole point of a capacitor is to store electrical energy. And back in the 50s, I guess it was, when televisions had lots and lots of big tubes in them, the capacitors could be pretty good sized, and they could hold a charge. When the set's unplugged, they could hold a charge for a couple of weeks, enough to give you a good jolt.
We're talking about a couple of 100 volts as well.
Okay, okay. All right, in the United States, what's
a great example of that you can show yourself? Your cell phone charger part that you plug into the wall has some capacitors in it. You can unplug it and then immediately plug your phone into it, and your phone will charge for like a quick second after unplugging your charger.
Interesting. I didn't even think about that. Thanks, Brad. Okay. All right, in the US, what circuit does the black wire insulation indicate in a 3-wire cable? And the black wire, okay, that's the hot wire. Yep, that's the hot wire. All right, what's a good way to guard against electrical shock? Should you use those 3-way cords and plugs for your AC alternating current powered equipment? Yeah, you should. Should you connect all AC powered station equipment to a common safety ground? Ooh, you bet you should. Should you install mechanical interlocks in high voltage circuits? Sure, all of those are correct. Okay. Where should you focus, or I'm sorry, where should you fuse a circuit breaker installed in a 120 volt AC power circuit? In series, with the hot conductor only. You do it in series because, if something goes wrong, the purpose of that fuse is to blow out and stop, current from flowing. All right, so you want it in the hot conductor. Okay.
You do have a different question for mobile stuff, attaching your cords to an automobile battery. Remember that, Bob, where you're supposed to fuse both lines,
Yeah.
or the hot and the negative.
Okay, but in this one, this is the 120 volt alternating current power circuit. Okay, so in that it's the hot conductor only. Okay, where should a lightning arrestor be installed in a coaxial feed line? And that's on the grounded panel where the feed line enters the building. Okay, what should be done to all external ground rods or earth connections? Yes, bond them together with heavy wire or conductive strap. Which of the following is good practice when installing ground wires on a tower? Ensure that all connections are short and direct. You remember, because what you're trying to do here is you're trying to give that electrical energy as short and direct a path to ground as possible. So the wires, big gauge wires, as straight as you can make them, no turns if you can at all do it. Absolutely no right angle turns. All right, so which of the following is true when installing grounding conductors used for lightning protections? Okay, yeah, sharp bends must be avoided. Yeah, right. The one above it, wires must be carefully routed with precise right angle bends. No, absolutely not. Sharp bends must be avoided. Okay, which of the following establishes grounding requirements for an amateur radio tower or antenna? Yeah. This one can seem tricky because, again, we're not talking about strictly radio stuff. So no, it's not the FCC. No, it's not the Federal Aviation Administration. No, it's not Underwriter Laboratories recommended practices. It's your local electric codes. Now, they may draw on stuff from other sources, but what's in the local electrical codes prevails. Which of the following conductors is preferred for bonding at RF? And again, that's a flat copper strip. When we're talking bonding for radio frequency, what we're talking about is connecting, making sure that all your equipment in your shack has a common connection, And the flat copper strap, again, provides the least resistance, the least impedance for RF. Okay, what's a symptom of RF feedback in a transmitter? Reports of garbled, distorted, or unintelligible voice transmission. Yeah. RF feedback. Which of the following could you use to cure distorted audio caused by RF? Okay, this is that ferrite choke. Remember I was showing you those examples from that from the photo of those little pieces that clamp over, for instance, like a television and antenna cord. Yeah, the ferrite choke, and that keeps the RF out of the television, or if it were a radio or whatever. Which of the following could cause radio frequency interference? Fundamental overload? Well, yes. Yeah, that's the big 50,000 watt station right next door that's overloading your system. Harmonics, which is just multiples of the frequency you're transmitting. Yep. And spurious emissions, that's emissions coming out of loose connections or malfunctioning equipment. Yeah, all those can cause interference. Okay, what would cause a broadcast AM or FM radio to receive an amateur radio transmission unintentionally? And that's when the receiver, what we're talking about here is selectivity. This is when a receiver is unable to reject a strong signal um, coming from outside the AM or FM band. Okay. Again, your televisions, your radio, they're supposed to be built so that they can filter out unwanted signals, but that doesn't always happen. Okay, how can fundamental overload of non-amateur radio or TV receiver by an amateur signal be reduced or eliminated? And that's block the amateur signal with a filter at the antenna input of the affected receiver. So this is where you're putting, for instance, a ferrite choke on the antenna cord going into the television. Okay, which of the following can reduce overload of a VHF transceiver by a nearby commercial FM station? Okay, and this is by installing a band reject. When we're talking about a commercial FM station, we're talking about a station that's going to be at a single frequency or a single range of frequencies and is going to stay there. So, you can have a filter that can specifically reject, can specifically block that frequency or the range of frequencies in that area. Okay, what should the first step to resolve non-fiber optic cable TV interference caused by your amateur radio station? Again, this is making sure that the TV feed line coaxial connectors are all installed properly. Yeah, when there's interference, kind of the first thing to do is, make sure that all the equipment is operating properly. The connections are what they should be. You don't have rusted out or oxidized connections or cables. Which of the following is a reason to use shielded wires? And that, of course, is to prevent coupling of unwanted signals to or from the wire. All right. Remember, any wire, whether you want your antenna to radiate signal, you do not want your feed line to radiate signal. So that's why your feed line, it's easiest if you're using shielded coaxial cable as feed line. There's other steps and other protections you have to go through if you're going to use window line or ladder line. Okay, which of the following actions should you take if a neighbor tells you your TV station's transmissions or your station's transmissions are interfering with their radio reception? Go ahead, Jerry, tell them. Tell them to go take a hike.
Yeah, take a hike. And well, I did see an old magazine cover when I was a kid. The guy looks out his window and he finds that the coax going up to his tower has been cut and tied into a hangman's noose.
Okay. Okay. Again, the first thing is make sure your station is functioning properly, and which includes that you have RF bonding in your shack, and that all your feed line connections are tight, that there's no loose or wobbling stuff. And then find out what station it's interfering with for your neighbor, and you turn on your own TV set to that same station and see if when you transmit, see if you're interfering with your own TV. If you're not interfering with your own TV, well, you're certainly not interfering with his, and the problem is somewhere on his end. And there's nothing you can do about that. Okay, what should you do if something in your neighbor's home is causing harmful interference to your station? Should you work with your neighbor? Yeah, you probably politely inform your neighbor that FCC rules prohibit the use of whatever device it is that causes interference. Make sure, and again, back to the old standard, make sure that your own station meets standards of good practice. Make sure your stuff is working right.
Right.
Okay.
Incidentally, the ARRL does have some facilities available to you if you have a very bad problem there are local experts that they can send to you to help you out.
Oh, okay.
Part of your membership.
Good to know. Okay, what type of radiation are radio signals? And that non-ionizing radiation. Yeah, remember that. Non-ionizing radiation. It's not going to hurt your genes. Your grandchildren are safe. Okay. Why do exposure limits vary with frequency? Yeah, because the body absorbs some RF energy at some frequencies better than at others, more so than others. Yeah. So you remember that chart I showed you where, when you're down in 80-meter band, down at 3 megahertz, the RF exposure limit, the maximum exposure limit is way higher than when you're in the VHF range. Okay. All right. What hazard is caused by touching an antenna during a transmission? Yes, RF burns. Yep, RF burns. How does RF radiation differ from ionizing? RF radiation does not have sufficient energy to cause chemical damage to the cells or damage DNA. Who's responsible for ensuring that no person is exposed to RF energy above the FCC exposure limits? Yeah, you are, the station licensee. Remember, that's when we were talking about determining the maximum permissible exposure in the controlled area and the uncontrolled area. The uncontrolled area when when civilians are involved. Okay. Oh, okay. Now this is the question I was telling you about when we were looking at the maximum permissible exposure chart. Okay, at which of the following frequencies does maximum permissible exposure have the lowest limits? The lowest limits. And remember, that's in the VHF area, the VHF range, so that's 50 megahertz. And yeah, remember, because it's between 50 megahertz and 300 megahertz. Okay, we talked about duty cycle a little bit, and this is how does the power density allowed change if you reduce your duty cycle from 100% to 50%? Well, the allowable power density, it decreases. How does, if the duty cycle changes?
Well, the duty cycle, if it's changes from 100% to 50%, then
Oh, you know what? I've got the wrong thing. This should be C, not B. It increases. If you're, I read this backwards. I read this backwards. I was reading it if it.
Wait, no. I think you're right the first time.
No, B is wrong. It's C. C is correct. If the dude, oh, wait a minute.
Changes from 100 to 50.
The allowable power density
decreased.
changes
It's decreased.
if the duty cycle.
No, for instance, if you
No, the allowable power density, if you're decreasing the duty cycle,
yes,
power density increases. The allowable power density increases. So this is actually in C.
you got it.
Yeah. Oh, you know what? I went back and forth on this, because at first I thought, well, wait a minute. And then I read it out. When I read it out loud, I read, oh, that's not right. So, okay. Because everything Jerry, everything we think about is maximum permissible exposure. But here we're not talking about maximum permissible exposure. We're talking about the power density. So it's a little different question.
Yeah, they're playing word games here.
Yeah, I know. Oh, and they got me. All right. Why is duty cycle one of the factors used to determine safe RF radiation levels? And yes, because it affects the average exposure to radiation. All right, because remember, when you're not transmitting, you're not getting exposed. Okay, what's the definition of duty cycle? during the averaging time. That's the percentage of time that a transmitter is transmitting. Okay? What factors affect RF exposure of people near an amateur antenna station? Oh, frequency and power level? Oh, you betcha. Distance to the antenna? Oh, absolutely. And the radiation pattern? Oh, yeah, the radiation pattern definitely has an effect. Remember, because if you're dealing with an omnidirectional antenna, you've got energy going out in all directions. Whereas if you're dealing with a beam antenna, directional antenna, in the opposite direction the beam is pointing, you have very little power going out that way. So yes, A, B, and C, they're all correct. Okay, and which of the following is acceptable method to determine whether your station complies with the exposure regulation? Can you can you open those wonderful 57 pages of the operating and engineering technology bulletin number 65 and go through all that? Yes, you can, assuming you stay asleep, or assuming you don't go to sleep while you're reading it. Can you do it by computer modeling? Yeah, you sure can. Or you can measure field strength using equipment. Yeah, all those are correct.
Right. I think you'd better rent it. The equipment's a little too expensive.
Use yeah, use that ARRL modeling software. Just go out there. It's free. It only takes a couple minutes. Okay. Can you make sure your station stays, well, how can you make sure your station stays in compliance with RF safety regulations? And that's by reevaluating the station whenever an item in the transmitter antenna system is changed. You change your transmitter, yes, recalculate. You change your antenna system, yes, recalculate. Okay, which of the following actions can reduce exposure to RF? Relocate the antenna. Yeah. How about relocating the transmitter? No, that has no effect on anything. Increase the duty cycle? No, that'd make things worse. Okay, so yeah, you move the antenna if you can, or when you put up the antenna, put it in the safest place you can.
Yeah, Bob, I have in my attic an antenna I've used for DXing and stuff like that before I had the beam. It's a pair of 20-meter dipoles, and they're probably about 10 feet above me, above where I'm sitting. And if I work 10 meters, that puts it in the wonderful zone.
Yeah.
And if I put it out 100 watts, I suspect, I haven't done any measurements, but I suspect that I would start getting a little adverse radiation there. So I don't operate 10 meters on that one.
Good call. Okay, which of the following is an important safety precaution to observe when putting up an antenna tower? And yeah, it's those overhead electrical wires. It's the utility power lines. Look for them and stay away. Stay away. Okay, what's the purpose of a safety wire through a turnbuckle? Okay. Even if you don't know what a turnbuckle is, guidelines, I'm sure you know what they are, but you put a safety wire through to prevent loosening of the turnbuckle due to vibration. And the vibration would come from, your antenna's outside. There's wind and rain and whatever that over the months and years will loosen things up a bit. What's the minimum safe distance from a power line to allow when installing an antenna? And again, here's that one, and I tell you, this can show up. And it's not just 10 feet away from the power line, it's far enough away from the power line that if it falls, it won't come any closer than 10 feet to the power line.
It's okay. Two stories. When I was living in Illinois, I saw a 90-foot ham radio tower, And I was a little iffy about that because we were in a high windstorm area. And one day I was driving to work and I saw the 90-foot tower stretched over 3 yards.
Ouch.
Ouch. And
Yeah.
second, if you let me share screen, I'll show you a turnbuckle.
Okay. Go ahead.
All right. Okay, everyone see this? Okay.
Yeah.
All right, a ham radio turnbuckle would have an eye on both instead of a hook. And you can see what this does. It adjusts the tension. So what they're talking about is putting a wire through, so just in case the you run out of screw threads, and the thing flops open, and it can do so by way of vibration, then at least you have something that's holding the thing together rather than letting the whole fixture fall apart and you lose the guy wire.
Hmm.
So that's the principle there.
Okay. Okay. All right. And what is the proper grounding method for a tower? And that's installing separate 8-foot ground rods for each tower leg. Okay? Bonded to the tower and to each other. Okay, separate 8-foot ground rods for each tower leg. And then just think back to that ideal diagram, the ideal grounding diagram that Jerry showed you, where each of the towers or each of the tower legs had ground rods. Actually, it had multiple ground rods on each tower leg, but anyhow, at least one 8-foot ground rod for each tower leg, and those bonded together. Okay, why should you avoid attaching an antenna to a utility pole? Oh, again, here we're worried about the high voltage power lines, the utility power lines. Yeah, don't do that. Okay, what is required when climbing an antenna tower? Should you have had sufficient training on safety tower climbing techniques? Gee, I hope so. Should you use appropriate tie-off to the tower? In case you slip, you're tied to the tower. That's a good idea. How about always wear an approved climbing harness? That's also a good idea. So yeah, all of those are correct.
And a helmet.
And a helmet. And it's kind of funny, but in this month's Popular Mechanics, they have an article about why why you should need a hard hat. All right, and it's an interesting little article, and it's a good thing to have, even if you're working, even if Jerry were to be working in his attic, because now in his attic, nothing's going to drop from the sky on his head, but depending on how high the ceiling is, some roofing nails come through the roof.
Yep.
And you don't want to stand up and run one of those through your head. That'd make for a very bad day. So
okay, one thing I'll tell you a Jerry story then.
Okay.
All right. Well, I've had several careers, and one of them was working for the Postal Service as an electronic technician and mechanic. And they made us wear bump caps, which were a sort of a smaller version of a hard hat. And at one point, I was doing some work over a concrete pit, and I lost balance and fell into the thing. Managed to break my shoulder, which it healed pretty easy. But I was wearing the bump cap, and that saved me from concussions and fractures. So it's a pretty good thing.
Yeah, really. Save your noggin. Okay. Under what circumstances is it safe to climb a tower without a helper or observe? Yeah, don't that's one of those things. Don't do that alone. Okay, which of the following is an important safety rule to remember when using a crank-up tower? All right, that type of tower, all right, you need mechanical safety locking devices installed on it to make sure that the tower doesn't retract while you're up in the air. If it retracts very quickly and precipitously, that would not make for a good day for you. That could lead to some really unfortunate injury. Ah, that's it. All right. Is everyone happy?
Other than being in the dark, yes.
Oh yeah, yeah. Oh, Brad,
You-
sorry about that.
What happened? You have a power failure?
Yeah, Brad's out of power. His
Yeah.
neighborhood's out of power.
Yeah.
So
Hey, just to throw one more little story about hard hats. Never knowing what's gonna happen. You know, people can, accidentally drop things from above and stuff like that. Or Warren Cert was you're doing their thing for the city of Warren during their what are they called? Their birthday bash, where they shoot off the fireworks in August. And the fireworks started shooting off, and it scared a bunch of a bunch of geese that were at the General Motors Tech Center. And one of them flew into the power lines right along Van Dyke there. And the power line fell down on top of one of our CERT guys, bounced off his helmet and landed on the grass. And he was unscathed
Wow.
because of the helmet. When the fire department got there, that line was live.
uh-oh.
So you never know. We were all thinking, and we were all sure that, the line broke, and it broke on the end, and the end that fell was not powered. Because nothing happened. We weren't seeing sparks on the ground. We weren't, no one was willing to go and touch it.
I hope not.
But when the fire department got there, that line was live. And so wearing that helmet, was a saver. So, just remember when you're doing tower stuff and you're helping somebody out with their tower, or you're doing your tower, wear that helmet.
Yeah. Assume the worst.
Yeah, you just never know what's gonna happen.
Hey, Bob,
Yeah.
Hugh Boyle here.
I am here.
Can I share one picture, please?
You are sharing. You are sharing. Yeah, you're sharing your screen with the crane and the tower.
Oh, okay. All right, good. That's the way you pick up a tower.
Yes. Yes, if you have access to $100,000 crane, that's the way to do it.
Do a tower.
Oh. Oh well. All right, let's see what else.
So anytime you're working with stuff overhead, you should wear a hard hat. When I was in
Absolutely.
the Army, I had the side panels to a 10-ton truck being lowered, and the people up on top of the truck lost the grip on it and dropped it, and they came down and slammed me in the head.
Oh, good Lord.
Yeah, but it was an accident.
It was, and no one was wearing our hard hats.
Thank goodness you were.
Well, you were wearing a helmet though, right?
I was not, because it was
Oh.
not a requirement.
Oh my.
Oh,
Yes,
wow.
so anytime you're working stuff overhead, just wear a helmet.
Wow. Well, I'm glad you're with us.
And for some scale, the tires of this truck were almost as tall as me, and I'm 5'2".
So anyhow, I have finished with chapter 9. Okay. And I was going to go back and do some of the questions for chapter 6 because we got a few minutes left, and I think it's worthwhile. Who am I hearing? Is that I don't know. Anyhow, I don't hear it now. All right. What I'm going back to is, we had left chapter 6 and we had gotten through the digital signals and all that. And I thought I'd go through some of the questions just to refresh your memory because we didn't go through the questions back at that time. And again, I'm just going to breeze through them. I've already got the answers highlighted, so it's not going to take a long time. So I won't go beyond my time limit. Okay, but let's go beyond, or let's go review this again. Review. It'll help you. All right. It's not necessarily fun. It's not sexy, but you know what? Hey, it will help you take your test. Okay. Now, what type of signaling, and we're talking about digital signals here, uses pairs of audio tones? And that is DTMF, dual tone multi-frequency. Okay. You remember that? All right. How can you join a digital repeaters talk group? And here we're talking about things like DMR and that kind of thing. How do you join a digital repeaters talk group? You program your radio with the group's ID code. Do you remember hearing about that? Things like what is that? The code plug and the color codes and things like that. Do you remember those things? All right. So you join a repeaters talk group by programming your radio with the group's ID code. Okay, what's the purpose of the color code? Okay, all right, I was just mentioning that. The color code used on DMR, and the color code, it must match the repeater color code for access. This is kind of like analogous to on an analog repeater having a PL tone, a subaudible tone, a CTCSS, control tone coded squelch system. Yeah, this color code, it has to match the repeater's color code or you don't get in. Okay, what function is performed with a transceiver and a digital mode hotspot? And that's communicating using digital voice or data systems via the internet. Yes, we get the internet into amateur radio. All right, and what does the DMR code plug contain? And that's access information for repeaters and talk groups. Hugh, you use DMR, don't you?
I do. Matter of fact, I'm on the Oakland County ARSPC net right now. But yeah,
Okay. And do you have any comments on code plugs or color codes?
color codes and code plugs. Yeah, that's you guys got to figure out what you want to use. There's DMR, there's Fusion, there's D-Star out there. DMR is really for commercial use, and they
Oh.
brought it into the amateur use. It's quite a learning curve, and I would not get that as your first choice of software-defined radio. Right.
Okay. Okay, thank you.
Right.
All right. All right. How is a specific group of stations selected on digital on a digital voice transceiver, and that's by entering the group's identification code. Okay. All these, color codes and plug codes and whatnot, and group identification codes. What this does is it allows stations to enter into speaking with specific groups while rejecting other signals. All right. All right. Which of the following must be programmed into D-Star digital transceiver before transmitting? Yes, your call sign. Okay, that's for D-Star. How is over-the-air access to IRLP nodes accomplished? Yes, by using dual-tone multi-frequency signals, DTMF. Okay, just when this IRLP question comes up, just think DTMF. IRLP, DTMF. IRLP, DTMF. And I just say that because there's a lot of these digital modes and these digital questions, which they have such their own little particular jargon, and sometimes this stuff is just easier just to memorize little code cues like that. Okay, and what is VoIP, Voice over Internet Protocol? Yeah, that's delivering your voice communications over the internet using digital signals. And this is, of course, like with IRLP, you're using your radio to connect or to contact an IRLP node. The IRLP node is then connected to the internet, which then uses the internet to send your signal out all over the world. And someone else using their radio picks up the signal from their IRLP node. And, with your 2-meter radio, even with your handheld Baofeng 5-watt handheld radio, you can be talking to Japan. Okay.
It's
right.
it's all very nice, but it's not suitable for emergency work.
Well, okay, that's right. But, what is the Internet Radio Linking Project, IRLP? And it's a technique to connect amateur radio systems using voice over internet protocol. Okay. IRLP, it's using amateur radio and amateur radio transceivers, hooking them into a node or communicating with an IRLP node, and then the IRLP node transmits the communication over the internet. Now, this is different from Echolink. There's a question coming up on Echolink. Echolink is a little different. Echolink also does use the internet, but with Echolink, what you do is you register with this group, the Echolink. You have to send them a copy, a photocopy, or a scan, really. You email them a scan of your amateur radio license, and they set you up on it. And then you can do amateur radio over your laptop, or for that matter, over your phone, with no with no ham radio equipment. Okay. So yeah, you can use Echolink without a ham radio transceiver. Sometimes, I live in a condominium, and so I can't put up a permanent antenna. When I want to put up my antenna, I have a nice old tripod and a nice mast that puts my 2-meter antenna up about 30 feet in the air. But on those Sundays when I want to check into the net, but I don't feel like putting up my antenna, I can just fire up my laptop here and using Echolink call into the Sunday night net with no radio interface at all. Okay, what's required before using the Echolink system? Yeah, I just told you this. You have to register your call sign, and you have to send them a scan of your amateur radio license. Yeah, you have to be a licensed ham to use that. Okay, and what is a talk group on a DMR repeater? And yeah, it's a way for a group of users to share channel at different times without hearing other users. It's, time sequence. Okay. Which of the following describes DMR? Yes, it's a technique for time multiplexing two voice signals on a single repeater channel, a single 12.5 kilohertz repeater channel. Okay, you got two signals going on, but they're kind of they're oftentimes
They
by just.
oscillate.
I'm sorry.
They oscillate between each other.
Ah, there you go. That's a great term. They oscillate between each other, right? So they don't interfere with each other, but the signals, oscillate. They interleaf. Okay. What does the term traffic refer to in net operations? Traffic, on net operations, traffic refers to messages exchanged by net stations. Oh, and which of the following is standard practice when you're participating in a radio net? I'll tell you real easy. Speak when spoken to. Okay, the net control operator will tell you when you can talk, and that's when you talk, and not other times. Okay, so unless you're reporting an emergency, and if you're reporting an emergency and there's a net going on, all you do is you fire up your computer, and if it's really an emergency, you just say break, break, and they should let you in, and you take care of whatever the emergency is. Okay. So yeah, unless it's an emergency, transmit only when directed to by the net control station. Which of the following, how am I doing on time? Okay, I don't have much left here. Which of the following are typical duties of the net control station? Okay, just call the net to order and direct communications between the stations, all right? So, you call the net to order, and then you let stations check in, and then you call on the stations in sequence or in order, and let them do their talking. Now, some station may come on and ask if they can talk directly to another station, and the net control operator will either say yes, go ahead, or no, not at this time. But you have to follow the orders of the net control operator. All right. What technique is used to ensure that voice messages containing unusual words are received correctly? Yeah, and spell the words using the standard phonetic alphabet. If you're sending the word Bob, you probably don't want to say Bravo, Oscar, Bravo. Bob's pretty common. But if you were going to send supercalifragilisticexpialidocious, maybe you might want to spell that. It'd take you a while. All right. Which of the following is characteristic of good traffic handling? All right. Now, in traffic handling, often what we're talking about is handling a communication from a third party to someone else. All right. So you don't want to be messing anything up. You don't want to be changing it. It's not your position to edit when you're passing messages. So you pass messages exactly as they are received. Your opinions or changes are not required. Okay, what information is contained in the preamble of the formal traffic message? And that's, information needed to track the message, obviously. Who's coming from, where it's going to, what the number is, how many words are there. Oh, okay. What is meant by check in radio, in the radiogram header? There's a box in the radiogram, in a formal radiogram, and the box it's labeled check. And what goes in that box is you put in the number, and that is the number of words that are in the message. So when the other person gets a message and in the checkbox is the number 10, that person wants to make sure that they have received 10 words in the message. Oh, what do we got there? I think that was, Aries, we went through that. What's RACES, Radio Amateur Civil Emergency Service? It is a radio service using amateur frequencies. Yes, it's using amateur stations for emergency management or civil defense. Yes, it's emergency service using amateur operators certified by the Civil Defense Organization. Sure, all those are correct. Okay, RACES. Okay, it's an FCC Part 97 amateur radio service for civil defense communications during emergencies. RACES, I believe, is part of Homeland Security or FEMA.
It is, in Michigan, it's administered by the state police.
Oh, okay, all right.
In other areas, well, I don't know, we have the ARRL with the Amateur Radio Emergency Service, which in Michigan, RACES is the actual vehicle, and the ARES supplies the manpower. In other areas, like in Denver, my daughter is a member of an ARES group, and they do the emergency stuff. The RACES is sort of a secondary thing, where they
Oh,
give all the powers to RACES, to ARES.
okay. And what is the Amateur Radio Emergency Service? A group of licensed amateurs who have voluntarily registered their qualifications and equipment for duties in public service. This is a wonderful thing to do if you have a permanent station. You know, if you're like me and you know your antenna isn't up all the time, and you know you don't have a powerful antenna, then this maybe is not appropriate.
Well,
But
no, if you go to different emergency services like the ARPSC, which is our sort of RACES and so on in this county, if you have a handy-talkie, if you have a mobile, they want you.
oh,
They
okay,
want you.
all
And
right.
if anyone is interested, so we can put you in contact with the ARES, or sorry, ARPSC boys, and yeah, you can both Macomb County and Oakland County have very active ARPSCs.
Okay.
Not
Now,
not to take away anything from the Mike's organization.
okay. When do the FCC rules not apply for operation of an amateur radio station? When do they not apply? Never. They always apply. Now remember, part of FCC rules, and it's right in Part 97, is that in times of emergency, when the emergency threatens human life or property, anyone is authorized to use any mode to communicate to save human life or property from, you know, damage. Okay, it's part of the rules. All right. Okay, you know what? That's about, I think, all we can do for tonight. We're right up against 9 o'clock here. So that's it. You know, I hope you guys have felt like you're ready to test. Actually, a couple of you already have. You know, 3 people from the class have already passed their tests. Chuck, Bradley, and Kurt. And so for the rest of you, for those of you in Southeast Michigan, our club does do testing on the first Tuesday of each even month. So for the month of April, we're going to be at the Oak Park Community Center doing testing. All you have to do is show up with, oh, first off, again, like we said earlier in the, I think it was in chapter 1 or chapter 2, you do have to get your FRN number. You get that from the FCC. But you just show up to the test site with your $15 test fee. We don't get the $15. It goes to the ARRL, and take your test. We've been through a lot of stuff, you know, and like Jerry told you right at the beginning, is that the amateur license test, it covers the coverage of subjects. It's a mile wide, but only 1 inch deep. You know, the test is not that difficult. Do study. Do make sure that you're taking those practice tests. And you know, and there are a number of places out you can get them. ARRL has them. QRZ.net has them. And take a bunch of them, and then good luck to you.
Yeah, and I also suggest that while you're taking those practice tests, you're waiting for the class to come up, and you're already getting, 90, 95, 100%, just about every time you take it. Why don't you also look at the general? Just take some practice exams there. Play around with that a little bit too. Because after you pass your technician test, they're going to hand you the general test for free. It's not another $15. You might as well take it. And heck, if you can pass it, and a lot of people do, you'll walk away there with your general license and not just your technician. And if you don't pass it, no harm, no foul. I didn't prepare at all. I just guessed my way through it. And if I'd have gotten one more right, I'd have walked away with my general. But I didn't. I had to get it later. So, if you feel like you are prepared and ready, look at the general a little bit too. Can't hurt.
Okay, and of course, the last thing we should leave you with is, I don't know, it's a slight downer. What you're doing is taking an exam, and you're getting a license by taking an exam. It's sort of like getting a driver's license by passing the rules of the road. Great, you know the rules of the road. You know some things about ham radio, but you're not there yet. What do you say when you click on the microphone? Things of that sort. How do you set up your own station? Things of that sort. That's what you need a radio club for. And we're blessed with quite a few radio clubs in the area. Our club is very active down in Livonia, Plymouth, Usika, up in Utica, Shelby, up Van Dyke Way. You have this is farther south around Wyandotte, W8 MRM, a big radio club there. So Milford has one, Lance Cruz. You've got quite a few clubs. Join, find yourself in Elmer, and get some help and some good advice in trying to set up your station and just operating in general. I've said my piece.
Yeah, and then just learn as you go. That's how you really become a ham. That's how you really learn this stuff, by doing it.
Yeah.
And contact any of us if you have any questions before you find a permanent Elmer, and we'll be glad to help.
Okay. I hope you are all ready, and go get them.
Thank you, guys. This has been fabulous.
Okay.
Is this the
Oh, Hal,
last
thanks for
question?
coming, Hal.
Yeah, let us know your call when you get it.
Okay.
Okay.
Is this the last class then?
This is the last class.
The last melon.
So yeah.
Okay.
So Brad, from here on out, you may want to start dropping in on the general class. That's on Monday night. That's in person though.
Yeah. I am wanting to start studying for that.
Either that or go right to the extra class. You're quite technical already. You've got a good technical background. That you might want to do that.
Yeah, I was looking into starting to study for that. I was thinking about just grabbing the study guides and reading them.
Yeah.
Yeah.
Great. Okay, one and all, thank you. And good luck to
Yes.
you.
Thank you.
Good luck, guys.
Bye.
Go get that license. Rock on.